lots of math YouTubers have recently come together to pick their MegaFavNumbers, to pick their mega favorite numbers, their favorite numbers over 1 million. Mine, I mean, it's well over 1 million. It's over Graham's number. So I'm going to, it can be written down like this: 3 arrow 65 arrow 2. How is this arrow notation interpreted? You might be familiar with Knuth's up arrow notation. It works a bit like this. Let's say you have something like 3 single arrow 3. That is just equal to 3 to the power of 3. 27. Not a big deal. Next up, what is 3 double arrow 3? That is 3 to the power of 3 to the power of 3 3 times. So this arrow notation is repeated exponentiation. Just like multiplication is repeated addition, or exponentiation is repeated multiplication, this is repeated exponentiation. So it's 3 to the 3 to the 3 3 times. Now this is equal to 3 to the power of 27, right? We saw that 3 cubed is, 3 to the 27. Well, this is around 7.6 times 10 to the 12. This is a big number. I'm not going to write it down in full. I didn't memorize it, so I can't write it down in full. But anyway, next up, 3 triple arrow 3. Triple arrow 3. How is this written? Well, this is, it's repeated double arrows. So it's 3 double arrow, 3 double arrow, 3. And remember that 3 double arrow 3 is this humongous 7.6 trillion number. This is equal to 3 double arrow 7.6 trillion. I don't know. I'm just gonna shove this in there. Which is equal to, 3 double arrow. So this is 3 exponentiated to itself 7.6 trillion times. It's a lot of times. Okay, I'm gonna stop here. And this is 7.6 times 10 to the 12. Anyway, I'm not going to do more examples of this because anyway, just adding one more arrow, it makes these numbers a lot bigger. Anyway, that is up arrow notation, which is not what we want. We want chained arrow notation. So let's do that. Let us figure out what chained arrow notation is. Next up, chained arrow notation. Chained arrow. So let's say you have something like 2 arrow 2. This is just 2 to the power of 2, which is 4. I can do another one. Let's do 2 arrow 3, which is 2 cubed. This is 8. 2 arrow 3 is 8. Actually, no, I can do another one. 3 arrow 3. This is equal to 3 cubed, or 27. So 3 arrow 3 gives us 27. No big deal just yet. But with these arrows, I can chain them. That's why they're called chained arrow notation. So let's say we have 4 arrow 3 and another arrow and then 2. This is equal to, okay, this is a theme that we're going to see when doing 3 arrows. Okay, so we have 4, so 4, and then 2 arrows, 2, and then 3. Now, okay, we've already saw up arrows get big, so this is going to give us, and now the number of arrows is controlled by this third number, so we can just make that big, and now we have a lot of arrows. Okay, so we have 4 up arrow 3. Okay, now, what is this? This is 4 arrow, 4 arrow, 4 arrow, 4. Like that, 3 times. Well, this is just 4 to the 4 to the 4. Or 250, okay, hang on. 4 to the 256. Which is on the order of 10 to the power of 154. 154 zeros. And that's just 4 arrow 3 arrow 2. Okay. Now, if we have the first 2 numbers are 2, that's going to be not very helpful. So this is 2 arrow whatever number, so let's just say 10. This is then going to be equal to just 10 arrows, which I'm just going to write like this because I don't know how. 10, 2. Now here's the thing. However many arrows you put in between 2's, you're always going to get 4. So this is now 4, and it's not that big. But we can get bigger. So we can get way bigger than this 4 arrow 3 arrow 2 just by putting the numbers in a different order. Just by switching the numbers into a different order, I can do it. I can get bigger. I can get bigger quickly. So let's just say we have 2, 4, arrow, 3. This is now equal to 2, 3 arrows, 4. This is now 2, double arrow, 2, double arrow, 2, double arrow, 2. We evaluate this. Okay, this is going to take us a while. 2 double arrow 2 is 2 single arrow 2. Okay, this is 2 double arrow, 2 double arrow, 2 single arrow 2. In fact, why do I write this? It's 2 to the 2, right? 2 squared, 4. Right? This is now equal to 2 double arrow, 2 double arrow 4. That is 2 single arrow 2 single arrow 2 single arrow 2. I'm not going to write that. That's just 2 to the 2 to the 2 to the 2. That is equal to 2 double arrow, 2 to the 2 to the 4, 2 double arrow, 2 to the 16, or 2 double arrow, 65,536. 2 double arrow, 65,536. This is a humongous number. It's 2 to the power of 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 2 to the 2 to the power of 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 2. Where the number of 2's is 65,536. So we have 2 to the power of 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 2 to the power of, and so on, where the number of 2's is 65,536. That is a big number. Just from 2 arrow 4 arrow 3. That's way bigger than the previous 10 to the power of 154, by the way. I can't even put it into standard scientific notation. Next. That is if we put 3 arrows, 3 numbers in the arrows. What if we put more than 2 of them? Let's say we put more than 2. What if we put more than 2 arrows? So we have 2. Let's say we have 2 arrow 3 arrow 2 arrow 2. the way these arrows work, let's say, okay, so we split it up into, so we have this chain, and then the last two. So we take this many copies of this chain. So this is going to be 2 arrow. So this is 2 arrow 3. That's 1 copy. And then we have 2 copies. So that's arrow 2 arrow 3. And then 1 less than this number copies of 1 less than this number. So that's 1 copy of 1. So that's 1. Okay, there we go. Now we can evaluate this chain. Well, remember, if we have a chain of 2 numbers, that's just the first one to the power of the second one. So 2 to the power of 3. No, 2. I just said it. Okay, 2 arrow 3 is equal to 2 to the power of 3, which is 8. So this is equal to 2 arrow 3 arrow 8 arrow 1. So we have 2 arrow 3 arrow 8 arrow 1. Okay, so we got a sequence of 4 numbers. We've got a sequence of 4 numbers again. Okay, then, final rule. Arrow 1s at the end can be discarded. So we can just remove this. So we get arrow 3 arrow 8, which, remember, this is 2 8 arrows. 4 5 6 7 8 3. I'm not even going to attempt to evaluate this number because it's so big. It's just so big. I'm not even going to do it. The thing is, we're almost in the big moment where we beat Graham's number with this notation, by the way. So, okay. One more example. 3 arrow 2 arrow 2 arrow 2. You see what I've done there? I have just put that 3 at the beginning. I've changed nothing. I've not changed the sum of the numbers, but I have changed the size of the number dramatically. Right? So we have, right? Now let's do the same thing again, right? That we did with the 4 numbers last time. So we have this, so we have the last 2 numbers and the chain before that. So we split it up into 3 components like that again. And then this is what we do. Again, we put this many copies of this chain, which is 3 arrow 2 arrow 3 arrow 2. Right? We have 2 copies of this chain. And then 1 less than this number of copies of 1 less than this. So that's 1 copy of 1, which is just 1. So let me put some sort of arrow in here. Okay, it's not really an arrow, but it counts. Okay, 1. Now what we do is we evaluate this chain, which is 3 arrow 2 arrow 3 arrow 2 is just 3 to the power of 2, so that is 9. Arrow 1. Arrow 1's at the end. They can be discarded, so we can do 3 arrow 2 arrow 9. Now I'm going to chain 3 numbers, which we can evaluate, just like previously, which is, we can evaluate it with 3, then 9 arrows. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 3, then 9 arrows, then 2. This is much, much bigger than the previous number. I mean, all we've done is we've switched the endpoints around, but remember, one more arrow, and the previous number is only minuscule compared to the result. So this is just very, very much bigger than the previous one. Okay, now we can get to Graham's number. So, for those of you who haven't heard of Graham's number yet, Graham's number is defined based on the up arrow notation, not the chained arrow notation that we just saw. Graham's number, so let's say we have 3 4 arrows, 3, let's call this G1, and then 3, and then G1 arrows, which is a lot of arrows, is going to be G2. Put a 3 there. G2. And then 3 and then G2 arrows. And then 3 is going to be G3. And so on. And so on. Until we get to 3 G63 arrows. And this is now going to be G64. G64. G64 now is Graham's number. It's a big number. As we've seen, the arrow notation goes up quickly. But what about the chain arrow notation? The chain arrow notation is just the up arrow notation on steroids. So, okay, here's how I'm going to beat Graham's number. First, I'm going to define a function. Let's just call it g, lowercase g, because it's a function. And I'm going to have n, and this is just going to be 3, and then n arrows, which I'm now, from now on, going to use this notation for. N arrows, and then 3. 3 n arrows, 3. So this is now g of n. Now we can actually beat Graham's number with this g of n function quite easily, because now what we do is we just say g of 4. That is G1. G of that. Wait, hang on. G of that. That's gonna be G2. G of that. That's gonna be G3. And so on. Until we have 64 G's. And this is now Graham's number. This is big G. I'm gonna call it big G. That's the Graham's number. Anyway, how do we beat this? How do we beat this number with chain arrow notation? Okay, now, remember the thing 3 arrow, 1. Remember, this is 3, and then a single arrow, and then a 3. Right? That's a single arrow. Now, how can we upscale that? Well, we just have, put parentheses on, 3 arrow, 3 arrow. That's 3, this many arrows, and then 3. And then we can do that again. 3 arrow, 3 arrow, this many arrows. So we get 3, this many arrows, 3. There we go. And so on. Three arrow, 3 arrow. This is now the 3 arrow, 3 arrow. Well, whatever. This is still smaller than Graham's number. We're gonna deal with that issue in a minute. And the reason why is because there is, we start with a single arrow instead of 4 arrows. For now, let's try to shorten this with chained arrow notation tricks. Now, okay, do we see any sort of repeated chain? We do. We see this 3 arrow 3. So we have, right? We have a repeated chain of 3 arrow 3. Now, I didn't put the arrow 1s on, but if I did, I could put like arrow 1, 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 and so on. So this is another repeated chain. In fact, if you count them, there are 64 of these and 63 ones. So, well, we can put those patterns in a neat package, which is a shorthand arrow. Which is a shorthand. So that's 3, arrow 3. Remember, this is our chain, and then we see 64 of them. So that's going to be 64 arrow, and then we put in one more than that number. So that's 2. This number is smaller than Graham's number. But we're almost there because remember, we only did 64 iterations. Now, on the first iteration, right, we started with a single arrow, not 4 arrows, which means that the second one we have 27 arrows, which means that if we just do one more iteration, we're going to beat Graham's number. How do we do one more iteration? We change this third number here. So we remove this, make it a 65. And then 2. And now we have a number that's bigger than Graham's number. This is bigger than Graham's number. So, okay, this chain arrow notation fanciness is my MegaFav number. It's 3, arrow 3, arrow 65, arrow 2. It's well over 1 million. It's well over Graham's number, in fact. But it's big. So, okay, that is my mega favorite number. 3, arrow 65, arrow 2. If you have your own mega favorite number, you can put the hashtag MegaFavNumbers in the video, and you put the word MegaFavNumber in the video title. It will automatically get added to the playlist with all of the MegaFavNumber videos, and I don't know, we can all see them. They're all gonna be in there. Yay!
It's a little bit of an homage to Ron Graham also, right?
Yeah. This is also called Conway's chained arrow notation. So
and to Conway then.
Yeah. So,
here you go.
There we go. Anyway, and see you the next time I'll see you. Bye.